Okay, here in this video, I want to give you a couple more examples of looking at the integral of the natural log. And the first example that we have here is the integral of 1 over x multiplied by the natural log of x cubed. So in order here to find the integral, we need to figure out what are we going to try to let u equal to? Well, there's a couple ways we can start off. If we want to rewrite this to make this a little easier, notice we have ln of x cubed. Well, again, using our logarithmic properties, we can pull this 3 out front. So we would have the integral of 1 over, and if we pull the 3 out front, I'm going to pull that all the way out front, so we get 3x ln of x. All right, and then notice we just have 1 over 3. This is a constant, so we can actually pull that all the way out front. Okay, and you certainly could do that in one step. I'm just trying to break this down for you. So pull out the 1/3 as a constant multiplier. And to help you see this a little bit better, I'm going to write this as 1 over the natural log of x multiplied by 1 over x. Now, if I rewrite it this way, I would ask you to maybe to pause the video and see if you can figure out what you want to decide to let u equal, and then see if you can continue and see if you chose correctly. All right, so hopefully you were successful with that. Here in this example, you're going to find out if we let u equal the natural log of x, then the derivative of ln of x is simply du over u, so that's 1 over x dx. So if you notice here, we certainly have our du, and ln of x is our u. So essentially what we have then is du over u. So if we have du over u, okay, so remember all of this is our du. So if that is over top of u, then that means we simply have the integral of du over u, which is the natural log. So therefore we would simply have 1/3 natural log of u. Okay, so it's the absolute value of our u. Now what is u equal? Well, u is equal to the natural log of x. So we would have ln of x. So you're taking the natural log of the natural log of x plus our constant. So there is our integral. So this one at first looks a little complicated with the 1 over x ln of x cubed, and you kind of have to break this apart sometime looking for that right pattern that's going to give you something that you can integrate. And in this case, it worked to split up 1 over ln of x and 1 over x. And if we let u equal ln of x, you need to keep in mind the derivative of ln of x, in this case, is 1 over x. So therefore, we have our du. Okay, and again, it just takes a lot of practice of working examples. The more examples you practice out of your book or off of the internet, you're going to get better at recognizing and seeing these patterns. So at first, it's going to take you time to struggle and try to guess what let u equal and finding the du, but give it some time. After you struggle for a few examples, you'll eventually pick up and be able to start looking at these and identifying them much quicker. All right, the next example is the integral of tangent 5 theta. And here, there's actually two ways we can work this problem. There's actually a integral formula for the tangent of theta. But instead of doing that, because probably most of us may not memorize that one, and if this is not one that you have memorized, then we could certainly rewrite this. Hopefully we know the tangent can be written as sine over cosine. So I'm going to write this as sine of 5 theta over cosine 5 theta. Now, one thing you need to make sure you realize here, this is just not tangent theta, but this is the tangent of 5 theta. So this is sine 5 theta over cosine 5 theta. And the 5 theta is going to be very important, so you need to be careful with this part of the problem. Now, the advantage of doing this, again, your first thought might be, well, we're going to let u equal the inside, which is 5 theta, but we're going to try to let u equal the denominator, which is cosine 5 theta. And when we take the derivative of u, we should know that the derivative of u is negative sine 5 theta. Now keep in mind though, now we have to take the derivative of the 5 theta. Okay, so here's kind of our chain rule. We got to take the derivative of the inside, so that's going to be multiplied by the derivative of 5 theta, which is 5 d theta. And if you look, we certainly have the sine 5 theta d theta for our du. The only thing we're missing is the negative sign in this extra 5. So we can certainly multiply in by negative 5 and then a negative 1/5 out front. So if you notice now, here we have du over u. And if we have du over u, then we know that's going to be the natural log. So if I bring down the negative 1/5, it's the natural log of u, which is cosine 5 theta. Okay, so there's one technique, and I think this is a good one, the way for you to work this out, because we probably memorize tangent sine over cosine, and then we know du over u is this natural log. Well, if we have the integral of tangent 5 theta, and you remember the formula, or you have a formula sheet or looking here, we know that the integral of tangent theta is actually equal to the negative natural log of cosine u plus c. So here, in this example, if we work it this way, then that means that we're going to let u equal 5 theta, and then if we take the derivative, du is equal to 5 d theta. And if we look at our problem, then we certainly have here our u. Okay, so here we have our tangent 5 theta, which is our u. And we have the d theta obviously, but we don't have the 5. So then here all we have to do is multiply by 5 and then a 1/5 out front. And then we have our tangent u du, or tangent theta d theta. So we could simply then use our formula, which is negative ln. So we have our 1/5, so that's going to make it a negative 1/5 natural log of cosine of u. Well, in this case, we would have our u is 5 theta, so that would be the cosine of 5 theta plus c. So you'll notice a lot of times with these integration problems, there's more than one way to solve them. And here, I guess you can kind of decide which one you prefer. The one on the left, I think, is a little bit easier if you're doing it from memory, because most of us probably don't memorize the integral of the tangent. But if you know the formula, then the one on the right probably is pretty easy as well. Just make sure that you realize this is tangent 5 theta and not theta. Most people forget when you take the derivative of u, you get this 5d theta, and you have to multiply the constant and then the 1/5 out front. All right, our last example here in this video is going to look at finding the area of a given region, and we've done this before. And we're looking at the area here that's given of this function, which is y equals x over x ln of x. And over here at the right, we have the graph. And we're asked to find the area between 2 to 4. And hopefully we can remember how to set this up. That's one thing you'll learn here, that you have to remember all the stuff we talked about before. So we're going to look at the integral to find the area underneath this curve down to the x-axis. Well, they give us the interval from 2 to 4, so obviously we're going to integrate from 2 to 4. And we have the function here, which is, and let's see, this is a little mistake here. This should not be an x. This should be a 2. This is 2 over x ln of x. So if we integrate this here, we're going to have 2 over x ln of x. So that's the function for our curve. And if we're going to integrate from 2 to 4, how will we set this up? Well, I'm going to start out we have the 2, and I'm going to pull that out front. The 2 is just a constant multiplier, so I'm going to see if we just pull that out front first and see if that helps us out a little bit. And also, I'm going to split this up. This looks a little familiar as 1 over ln of x. And then we can take the 1 over x and move that to the side here. Just split this up. And hopefully you can kind of see that we're going to let u equal, just like we did in a previous example, ln of x. And then the derivative of u is going to be 1 over x dx. So here we have 1 over x dx is our du, and the ln of x is u. So what do we have? We have du over u, and if we have du over u, that's our natural log, so I'm going to bring down the 2, and then we would have the 2 multiplied by the ln of u, which means we're looking at the u is ln of x. And notice we don't have a plus c because we have our limits from 2 to 4. And remember, when you substitute in the limits here, we're going to have our 2 out front. And if you plug a 4 in, I'm going to go ahead and calculate this. If you plug a 4 in for the natural log of 4, and then you take the natural log of that number, you're going to get approximately 0.3266 minus, and now we're going to plug the 2 in. So remember, it's the top minus the bottom. So if you take the natural log of 2 and then the natural log of that answer, you're going to get a negative 0.3665. And if you calculate this out, your answer is going to be approximately 1.3862. Okay? And there's your answer. Now, be aware that sometimes if you look in the back of your book or maybe on some of the quizzes that I give you, they may actually just leave this by plugging the number in as the natural log and leaving the 4 there to leave it as an exact answer. But there's certainly nothing wrong with going ahead and calculating this to get an approximation. So here you have a few more examples of looking at the integral of the natural log. Just keep practicing these examples, and I think you'll be good with integrating. Just make sure you keep looking for different patterns. As I've warned you before, don't always try to fit the integral to one particular format. You have to keep an open mind so that when you look at a problem, you have different techniques to try, but don't always get stuck into the rut of looking for one particular pattern or trying to force something to be du over u when it may be just a basic u substitution.